Hey everyone, let's look at some 6.3 now. This section's on the graphs of sine and cosine functions. So if you think about some real world applications of sine and cosine, things in daily life often repeat, like weather, tides, hours of daylight, lots of examples. Here's a graph with a normal heartbeat, and you can see that there's definitely some repetition in the graph. Typically, graphs that have repetition like this can be modeled with trigonometric functions. They're said to be periodic. Anything that's periodic repeats like this in regular intervals. Another word for an interval that repeats is a period. So let's take a look at what a graph of the sine function would look like. So think of now the sine function as f of x equals sine x. So here the input x is going to be an angle in radians, and then the output is the sine of that angle. To find and fill out this table, you could use the unit circle from 6.2. For example, if x is equal to 0, I need to figure out what is the sine of 0. Right? So if I'm starting to fill out this table, I want to calculate, I'll fill this one in, the sine of 0 radians. Lots of ways you can do that. I guess you could do it in your calculator. But what is going to be most useful for you, I can go back to the 6.2 notes, is that the unit circle, right? This is what on page 2 of your 6.2 notes. So I'm talking about the angle 0. The sine of that is the y value, right? And then in that table, we have the next one is pi over 2. The sine is the y value. The next one is pi, y value, 3 pi over 2, y value, and then 2 pi, y value. Okay, so that's where I'm getting these numbers when I fill in this table. Okay, so let's go back there and put those in. So the sine of 0 we saw was 0, pi over 2 was 1, pi was back to 0, 3 pi over 2, negative 1, and 2 pi is 0. Okay, now what I would like to do is graph that on an x and y axes, and we're doing it different than the unit circle. Now your input, the values along the x-axis, let's go down here, are angles and radians. And then the values on the y-axis are the values we got as the outputs there, the y values in the unit circle. Okay. Remember f of x, we use f of x a lot, the same as y. Maybe you've seen it that way more. Y equals sine x. Okay, so if I'm going to label this, then I'm going to put my gradient measures along the x-axis, right? In intervals of pi over 2 units. Okay, so 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. That's consistent. And then my y-axis, I can label it as however I want. The max is 1 and the min's negative 1. So let's just go ahead and use it all. Okay, so then we have our axes labeled, and now I'm going to plot these points. So I have that first point, 0, 0. I can just get them in there. That. The second point, pi over 2, 1. The third point, pi over pi, 0. And then 3 pi over 2, negative 1, and 2 pi, 0. And we see if we connect these dots with a nice smooth curve, you have this nice oscillating graph. And that's just from 0 to 2 pi. Now we could keep on going, and it's just going to repeat. That pattern will repeat in that same shape over and over, right? The next would be 5 pi over 2, 6 pi over 2, 7 pi over 2, and it's always going to oscillate 0, 1, 0, negative 1, 0, right? Okay, so that's the graph of the sine wave. How about cosine? Cosine, let's do in red. I can go back to the unit circle. If you look at the unit circle where I'm getting these points, you'll see the x value. I'll just go back there. We're looking at the first coordinate on the unit circle. Gets a little confusing with all the x's and y's and f of x and what are we talking about? But remember, cosine, when you're looking at that unit circle, is the first coordinate, right? So now I'm looking at these, right? Pi over 2 is 0. Pi is -1, 3 pi over 2 back to 0, and 2 pi is back to 1. Okay, so I'm going to be plotting those points. Okay, so at 0 was 1, pi over 2, 0, pi was -1, 3 pi over 2, 0, and 2 pi 1. And let's plot those. So we have 0, 1, pi over 2, 0, pi is -1, 3 pi over 2, 0, 2 pi 1, and then just a nice smooth continuous curve, and I get the graph of cosine. So these are one cycle of each sine and cosine from 0 to 2 pi, the pattern of those two graphs. Good to refer to this when you're doing graphing. This will help a lot, that pattern that you see there. It's good to know the pattern of sine and cosine. Now, how this relates to the unit circle, I can show you a quick little animation which might help too. So I'm going to share my computer screen. This is a website called Desmos, and it does a lot of animation with all sorts of mathematics. So here's my unit circle, and I'm going to see what happens as I unravel this unit circle where, again, my angle is the x-axis, and then the output is the y-axis. And this is for the sine graph. Just hit play. And you can see as I go around the unit circle and sort of unwrap it, it generates that sine wave. Okay. Ooh, going backwards too. Okay. So it's just going to keep going back and forth. All right. So that's an animation that shows the relationship. If I just pause it real quick, let's go a little further, maybe right there. Things that I'm noticing, this angle right here in radians is the length of that arc, right? That's the definition for radian measure. So that arc length right there then would be the same as this distance right here to the point, right? That's the input. The output is the y coordinate on the unit circle, which happens to be this red line, right? So that height matches this height. Okay, so that's the idea. All right, back to the handout. We'll get more into this. So next, we saw my password for my iPad. We're going to generalize some things about these graphs, right? So at the top of page 2, I've given you 2 cycles of the sine and cosine waves, okay? So from -2 pi to +2 pi, right? Notice how it repeats, right? We've got the pattern repeating, okay? And then this is just describing in words what happens with the graph, right? From 0 to 2 pi, what happens to each one, right, etc. Right? Does it increase or decrease? Okay. We'll talk about domain and range. Right? Domain and range. Domain, remember, are all the x values, and this one is just -infinity to infinity, right? This graph just continues indefinitely on the x-axis. However, the range are the y values. Notice the maximum that it will ever reach is +1, and the minimum -1 stays and oscillates within those 2 values, right? So never going to be above 1 or below -1. Okay, so that's the range. Intercepts, we can generalize the intercepts. That's where it crosses the x-axis. So the intercepts for sine x, notice are pi, 2 pi, 3 pi, 4 pi, 5 pi, or just n pi. Okay. Whereas for cosine, they're the fractional pies, right? Half pi, 3/2 pi. The next one would be 5/2 pi. So Those are odd number of pi over 2's, which here's a way to write it, 2n plus 1 over pi over 2. Right? 2n plus 1 is a fancy way just to express any odd number. Okay. When you talk about the period of a function, that's the length of a cycle. Right? So here, when does it start repeating? Right? So notice here, the length of one full cycle is 2 pi. That matches it. That's also 2 pi. Right? Same for our sine, 2 pi, 2 pi. So the length of a cycle is 2 pi. That's called the period. Okay. And then the last thing we'll talk about in this section is amplitude before we get into graphing different functions. The amplitude is half the difference between the maximum and minimum values, right? So half the distance, right? This one's, let's look at this. Okay, you're going from -1 to 1. That's a total distance of 2 units, right? 1, 2 units. Half of that then would be 1. Half of 2 is 1. Okay, so the amplitude is 1 for these graphs. Another way to think of it, it's from the middle of the graph to the top of the graph. That's a distance of 1. Okay, so both of them have amplitude 1. There we go. Okay, let's continue. Let's do a graph that's now we're going to kind of play around with the graphs and make them more complicated, right? So anytime you have a number out front of a sine or a cosine, then the amplitude is just that number. Ignore negatives. That's why there's absolute value on this. Okay. The only thing a negative is going to do, if a is negative, it's going to reflect or flip that graph upside down. Okay, so an example, let's graph f of x equals 3 sine x between -2 pi and 2 pi. All right, so I'll just stick with red here. That's going to be my 2 pi, and there's -2 pi. And then if that's 2 pi, this is pi. Half of pi is pi over 2, and that's going to be 3 pi over 2. That's those standard values. I have the negative side too. It's just the same numbers, but negative. Okay, so I've labeled my x-axis. Okay, now this 3 just tells you that the amplitude is 3. That means the maximum is going to be 3 and the minimum -3. Right, so right here is going to be the max. Let's label that 3, and then down here, -3. All right. Now, how to get the graph? You don't have to sit there and plot points. You can just do the sine pattern, right? So this is sine. Let's just do it in blue. Sine is always, let's do the positive one first. Starts in the middle, goes up, middle, down, middle. Okay. That's one of the cycles. Now think about how that's just going to continue. This one is going to continue going down to here, and then back to here, back to here, back to here. Like you wouldn't have a sharp turn going up that way, right? It's going to just keep going in the direction it's headed. Right? All right, and then you see there's 2 cycles. Both of them are identical as far as the pattern goes. And there's the graph. All right, let's try another one. Here is 3/4 cosine x. All right, the amplitude then is that number out front, 3/4. So I guess I'll go with the way I did the last one. Again, 2 pi, pi, -pi, 2 pi, -2 pi, right? And you know those intermediate values, pi over 2, 3 pi over 2, etc. So now how am I going to label my horizontal axis? Well, I have a maximum of 3/4. I can label this any way I want. So I'm going to do it like this is 1 unit right here, right? And then that's a half, that's a quarter. So that's 3/4 right there, right? And then same with down here, -1/4, -1/2, -3/4, -1. That's really clear, right? Okay. I'll clean that up when I rewrite these notes. Okay. So now let's graph it. Cosine pattern. What does the cosine pattern look like? Got it memorized yet? It looks like, where is it? that thing, right? Top, middle, bottom, middle, top. Okay, so let's do it. So I'm going to do the positive side first. Top maxes out at 3/4. Middle, bottom, -3/4. Middle, top. There you go. And then it should look exactly the same on the negative side. Middle, middle, top. All right, and continue it on that way. And there's your graph, okay? So you're getting used to, in this section, graphing different sines and cosine waves with some little translations, reflections, stretches, that sort of thing. All right, so far we've just really done amplitude. In the next video, we'll tackle some different periods and that kind of thing. All right, so I'll stop there for now. That's up through page 3 in the 6.3 notes. I hope all is well with you. Talk to you later.